Hey guys, okay, we are going to try this out and see how it works. I told you guys to make sure you log in and watch this video. Okay, we are going to take notes, and I'm going to just label them for just tonight's date. And the title is Scientific Notation. Now, as you can see, it's my voice and it's my handwriting, okay? And even this squeaky chair. Now, what you need to do is I will take my time and I'll go slow. You need to make sure that you are copying these in your composition book, because these will serve as your notes to go back and study and look over. Now, you can pause this at any time and write down what's on here. If I go too fast, I will keep that in mind and make sure I go slow enough for you to copy things down. Okay, first of all, I'm going to start off with a definition. Okay, and I'm going to define scientific notation. Okay, and a scientific notation is just a concise way of writing very large or very small numbers. Okay, now you'll see scientific notation used quite a bit in science. Okay? Now, scientific notation is going to take the form of this. And what this means is A is a number greater than or equal to 1 or less than 10. Okay, so greater than or equal to 1 or less than 10. Basically, it's a one-digit number, meaning all I can have is one digit in front of a decimal. N is going to be the number of spaces we move the decimal. Okay, so let's look at our first example. Example 1A. If I give you the number 5,320,000, okay, that's a very large number, and we want to write it in a more concise way, so we're going to use scientific notation. Now, as I said, we want to write it in this form. Therefore, I need to put a decimal place in my number where there's only one digit. So if I go and I start moving, and if let's say I want to put it here, that's not one digit in front of my decimal. I need to move it all the way to here with one digit in front. So then I rewrite it as 5.32. Make sure you put every digit. Now my zeros I don't need. So 5.32. Now, times 10, which is always going to be there. Now I've got to decide my exponent. Well, what I'm going to do, and I always call it this, I count from my want to my original. Okay, so what am I going to do? This is where I want it to go. Now, the original decimal place isn't there, but it's understood to be right there at the end of our number. So I'm going to count from my want back to my original. I'm going to go 1, 2, 3, 4, 5, 6 places. Well, think of a number line. What numbers are to the right of 0 on a number line? Positive. Therefore, it's going to be a positive 6. So let's try this one. Okay, well, like I said, one digit in front of the decimal, so hopefully you put your decimal place right there, leaving me one digit. So I'm going to write my number as 2.36 times 10 to some power. Want to original. Here's where I want it. 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces. And I move 9 spaces to the right. Therefore, it is a positive number. And let's do another one. Okay, 5,000. You try this one. And again, remember, you can pause this at any time, and then you can resume it. Okay, where do I want my decimal? I want it to go here. One digit. So my number is going to be 5 times 10 to some power. Want to original. 1, 2, 3 spaces. Therefore, it's going to be positive. Okay. Now let's look at this. Example number 2. Okay, 0.0000721. Well, right off the bat, you should think, well, it's a small number, and if bigger numbers were positive exponents, then small numbers should be negative exponents, and that's the case. Well, I need to move my decimal to where there's one digit in front of the decimal. And remember, it's greater than or equal to 1 and less than 10. Okay, so I need to move my decimal place to right there, to where there's going to be one digit in front. So that's going to give me 7.21 times 10 to some power. Well, remember, want to original. 1, 2, 3, 4, 5, 6. And I'm moving 6 places to the left. And what numbers are on the left of the 0 on the number line? Negative numbers. So it'll be a -6. Again, small number, negative exponent. Okay, well, let's try this one, 0.000473. I want my decimal point there, so there's one digit in front of my decimal. So it's going to be 4.73 times 10 to some power. Want to original. 1, 2, 3, 4. And again, 4 spaces to the left. I'm going to make this bigger. 4 spaces to the left, so that's a -4. Okay. Well, now let's look at these problems. What if I give you the problem and it's in scientific notation and I want you to expand it or write it in decimal notation? Well, 3.35 times 10 to the 4th power. Well, we said if my exponent is positive, then it's going to be a large number. If my exponent is negative, it's going to be a small number. Okay? +4, think of which direction do I need to move on the number line. Or which direction is positive on the number line, and it is to the right. So I'm going to move my decimal 4 places to the right. 1, 2, 3, 4, and then fill in any empty spaces. So the decimal notation of 3.35 times 10 to the 4th is 33,500, which makes sense because a positive exponent is going to give us a big number. Okay, well, if a positive number gives us a big number, then a negative exponent is going to give us a small number. I'm moving 4 spaces in the negative direction, which is left on the number line. So I'm going to take this 5.672 and move it 4 spaces to the left. And then fill in any empty spaces. So the decimal notation of 5.72 times 10 to the negative 4th is written as 0.0005672. What you need to keep in mind, again, negative exponents are very small numbers. Positive exponents are very large numbers. Okay, I want you to try these and make sure you bring them to class tomorrow. Okay, the first one. Okay, write that number in scientific notation. Write that number in scientific notation. Okay. Then on number 3, I want you to write it in decimal notation. And then number 4, the same thing, write in decimal notation. So make sure you bring these 4 answers to class tomorrow, and we will talk about them. Okay. Again, to sum it up, scientific notation is just a concise way of writing very large or very small numbers.